Hi, all CHEMMaster official YouTube channel followers. I hope all of you preparing well, and our poll questions might help you. And my suggestion is that just make the target of poll questions to reach 25 likes or responses to get early answers on each and every poll question. So here I'm going to analyze a typical question. So just look at the given tungsten complex. Is it 14 electron complex or 16 electron complex or 18 electron complex or 20 electron complex? To answer this question, we need to look at a deep concept or deep conceptual analysis. Okay, right. Now, try to draw the structure of given tungsten complex. Here we have 4 ligands. One is CO here, and the other 3 ligands. Here we have given with OR, CCR. That means you can expand this ligand. Okay, so this is the ligand. Now, we know that alkyne can contribute 4 electrons or sometimes 2 electrons based on the requirements for the total valency electron contribution to make that particular complex as stable or unstable. Okay, right. Now, just look at the tungsten again. We know that tungsten belongs to chromium family, chromaltung. Okay, so when you move down in a group, what happens? Regardless of the effect of ligand, the valency electrons always paired up in heavy metals when we move from 3D to 4D and 4D to 5D. Okay, right. So that's why here, just look at tungsten. Tungsten is having D5S1. So just try to draw the orbitals here. Okay. Now 1, 2, 3, 4, 5 and 6. And as we said, it is 5D metal. That's why regardless of ligands, all the electrons will be paired up. Okay, just listen carefully. So the six electrons are paired up like this. Now you can see each CO contribute 2 electrons. Okay, then here is the CO, here are the 2 electrons. Now just consider, for example, if all these 3 alkynes are 4 electron donors, then what happens? We can see here alkyne. So 2 electrons here, 2 electrons here. Okay, now the next alkyne, 2 electrons here and 2 electrons here. Okay, then here we have next alkyne, so which is contributing 2 electrons here, and for the next 2 electrons there is no availability of d orbital or empty valency orbital. That's why we can say that the 20 electron complex is not possible for this tungsten in given coordination with that given ligands. Okay, right. So we can simply eliminate this 20 electron complex, and here you can simply understand that if the 2 alkynes are 4 electron donors and if 1 alkyne is 2 electron donor, then it will fulfill and it will leads to D2sp3 hybridization. Okay, so here 2 alkynes must be 4 electron donors and 1 alkyne must be 2 electron donors in this case. Now just count the total electrons here. Tungsten contributing 6 electrons and CO contributing 2 electrons and 2 of the alkynes contributing 2 into 4, 8 electrons plus 1 alkyne is contributing 2 electrons, total 18 electrons. This is the possibility because all the available orbitals are packed with the electron contributions of alkynes and CO. Okay, now just consider why not this alkyne as a 2 electron donor here. For example, if it is a 2 electron donor, then so just check it once again. Just draw the orbitals once again. Here S and here P. So the 6 electrons are paired up here. Now CO just taken up its place here. Okay. Now, for example, if alkane is a 2 electron donor, then 2 electrons are given to this, and here the next alkyne is a 2 electron donor here. Then just take the next alkane here. Now here we have empty orbitals. Whenever the empty orbitals are present or valency empty orbitals are observed, then the extra pi electrons automatically move into that empty orbital. Okay, so and this makes alkyne as a 4 electron donor. Okay, here 4 electron donor. That means if we consider all the alkynes as 2 electrons donors, it is not going to fill all the available orbitals in its valency orbitals of tungsten. That's why here the all alkynes are not going to act as 2 electron donors, and all alkynes are not going to act as 4 electron donors. So simply 2 alkynes act as 4 electron donors and 1 alkyne act as 2 electron donor to make the tungsten complex as a stable complex with 18 valency electrons. Okay, so here the third statement, third option is the correct one, and this question is picked up from our online test series on chemmasters.online. You can practice high standard online test series from chemmasters.online website, and you can also get the best conceptual courses. So if you are interested, you can visit and join on chemmasters.online. Thank you very much.